Welcome viewers, in this video we will see the digital register. The type is serial in parallel out, SIPO type of register. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, serial in parallel out digital register. In serial in parallel out register, the data input is given bit by bit serially. We are passing the data serially. For each clock pulse, the input data at all the flip-flop can be shifted by a single position. The output at every flip-flop can be received parallelly. So here we are using the flip-flop. So flip-flop is the temporary storage device. By using flip-flop, we constructed the register. The data is given serially, bit by bit. For every clock pulse, the flip-flop is resetted. The data is changed. Because of parallel output, we are taking the data in a parallel manner. Now we'll see the block diagram. So this is the block diagram of the serial in parallel out flip-flop. So register. There are 4 flip-flops available. So we can store 4 bit of data. We are using the D flip-flop. What is the nature of the D flip-flop? The D flip-flop is the input D, Qn plus 1. So this is the input to the flip-flop. The present state. Qn plus 1 is next state. For a D flip-flop, whatever may be the present state, the D input will be reflected in the next state. Whatever may be the present state. If the D is 0, the next state also 0. If D is 1, next state is 1. The same input what is reflected as a next state of the flip-flop, whatever may be the present state. So that will be very useful for transferring the data. The data what we are sending is same thing will be available at the output of the flip-flop. If we send 1, 1 will be available in QA. If we send 0, 0 will be available in QA, whatever may be the previous case. That is the nature of the D flip-flop. The next state is purely depends upon the input. It is not depends upon the previous state. Right. So based on that, we are constructed the register using 4 flip-flop. Flip-flop 1, 2, 3 and 4. It is termed as A. DA, QA, DB, QB, DC, QC, DD and QD. The data is given serially. Input is given serially, bit by bit serially. They are taken as output as parallelly. QA, QB, QC, QD parallelly. Right. The data we need to transfer is 1101. We need to transfer the data 1101. Right. See this, initially all this flip-flop is reset 000. The output of all the flip-flop is 000. In step 1, we are sending the data 1. For a input is 1. What will happen? If the input is 1, the data will be transferred. This 0 will be transferred to next flip-flop. Right, the 0 what is available go to, the 0 what is available QA will go to QB. The 0 available in QB will go to QC. 0 available QC will go to QD. That is, the data will be transferred. So it become 1000 in the first clock pulse. In the second clock pulse, we are sending again 0. We are sending data input as 0. What will happen? This 1 will transfer to the next flip-flop. This 0 will transfer to the next flip-flop. This 0 transfer to the next flip-flop. So what will happen here? 0, 1, 0, 0. After applying the second flip-flop, second step, the data become like this, 0, 1, 0, 0. The third step we are sending 1 again because the data is 10, 10, 11. So the 1. So the 1 is given in the third clock pulse. What happened? This 0 will transfer to the next flip-flop. This 0 transfer to the next flip-flop. This one transfer to next flip-flop. This 0 transfer to next flip-flop. Now it become 1010. After applying the third clock pulse, third data, the status become 1010. The fourth step again we are sending 1. 1 as the data. Right. So the QA become 1. What is available in QA? It goes to the next flip-flop. This 0 goes to next flip-flop. This 1 goes to next flip-flop. So it become 1101. So So that is our required data 1101, right? So after 4 step, the data what we need to transfer is available as the output of the flip-flop. So initially all are 0. The first step, this 1 is transferred. While transferring the 1, this data what is available QA will go to DB, QB will go to DC, QC will go to DD. Like that the data will moving. Again we are sending 1, 0. At the time this 1 will go to the next stage. Again we are applying 1. This 0 will goes to next state. 1, 1 position shifted. Again applying 1. This 1 0, this one are shifted. So finally we got 1, 1, 0, 1. Right. Now we'll see the description. In SIPO shift register is shown below. The circuit can be built with a 4 D flip-flop which are connected as shown in the diagram. Serially it is connected. Where the clock signal is given additionally to the clock signal to the all flip-flop to reset. The first. So here the clear signal also available in the diagram apart from the clock signal. The first flip-flop output is given to the second flip-flop input. Like that the 4 flip-flops are connected in serially. Right. See the diagram here. So the clear input also available. Right. Now we'll see the 4, we are applying 4 clock pulse, we will see the detail. Initially all the output will be 0. So without clock pulse all the data become 0. Let take the 4-bit data is 1101. If we apply the first clock pulse 1 to the first flip-flop, the data to be entered into the flip-flop. Right. Initially all are 0. The data what we need to transfer is 1101. So that during the first clock pulse we are sending the data 1. So that will enter into the first flip-flop. So QA become 1 and the remaining all outputs are QA, QB, QC, QD will be 0. So we got 1, 0, 0, 0. If we apply the second clock pulse 0 because the data is 0 to the first flip-flop, then it become 0. The data already available in QA is transferred to QB, so it become 1. QC and QD already 0, so it becomes 0, 1, 0, 0. If we apply the third clock pulse as a 1 because the data is we need 1, 1, 0, 1, 1, 1, 1, 0, 1. So we are applying third clock pulse as 1. So what happened? Again QA become 1, QB what is available in QA already 0 will become QB become 0. Now QC become 1 and QD become 0. The data will be 1, 0, 0, 1, 0, 1, 0. So while applying the fourth clock pulse as a 1, what happened? Again the data is shifted. QA become 1, QB become 1, QC become 0, QD become 1. One step is moving. So the fourth data output will become 1101. So the required data is available at the output. Right. So what we discussed in the diagram, it is given in the description. Now we'll see the truth table. The data what we need to store is 1101. So initially all the outputs are 0. The first clock pulse we are applying 1. This starting from LSB. First we need to apply 1, 0, 1, 1. So first 1 is applied. What happened? This QA become 1. The data what is available, the other remainings are 0. The remaining data are 0. In the second step the 0 is applied. The 0. So this one will move to the next flip-flop. The 0 move to the next. The 0 move to the next flip-flop. So now it becomes 0, 1, 0, 0. In the third step we need to apply the third digit 1. So QA become 1. What happened? The previously available QA 0 is transferred to next flip-flop. This one transferred to next flip-flop. This 0 transferred to next flip-flop. So it become 1, 0, 1, 0. In the fourth clock pulse we are applying the fourth digit 1. So QA become 1 now. The already available QA 1 is transferred to the next flip-flop. This 0 transferred to next. This 1 transferred to next flip-flop. So finally we have 1, 1, 0, 1. So that is our required output. Right. So initially 0 we are sending this data. First 1, 0, then 1, then 1. First 1, 0, 1, 1. While applying the bits one by one, the data are moving to the next flip-flop. It is shifted. So finally we got 1, 1, 0, 1. Now we'll see the waveform. Clock pulse along with the 4 different output. So this is the waveform is available. This clock pulse is there. So we are applying the 4 clock pulse. 1, 2, 1, 2, 3, 4. Initially all are 0. So first we are applying QA as 1. So that the data what we need to transfer is 1, 0, 1, 1 starting from LSB. Right. So 1, 0, 1, 1. First 1 is applied. So it become 1, 0, 1, 0. Right. So after that this 1 will be transferred to the next. This 0 is shifted. Now become 0, 1, 0, 0. Right. After third clock pulse this 0 will be shifted. So it becomes 0, 0, 1, 0. Right. And fourth, this 0 will be transferred. Now 0, 0, 0, 1. So this is our record output. 1, 1, 0, 1. This is the LSB. 1, 0, 1, 1 will be available at the output. Right. So after applying the 4 clock pulses, the data is moving. This 1, initially 1, that 1 is transferred to the next. And also the next. Is keep on serially while applying the clock pulse. This 1 is keep on transferring. This 0 also keep on transferring. This 1 also transferring. Finally this 1. So 1, 0, 1, 1 will be available at the output. So our record output is 1, 0, 1, 1. That is our, this is LSB. This is MSB. Right? The MSB stored in QA, LSB stored in QD. So in this video we discussed the serial in parallel out register. We discussed the block diagram. We discussed how the data is transferred. We taken the sample data 1, 1, 0, 1. We are applying the data one by one. 1, 0, 1, 1. Then how it is moving we discussed. And also we discussed the truth table and waveform. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.